Our class, today's lesson is on solving quadratics by graphing. And so the graph of a quadratic function is called a parabola. Parabola. Okay. And the highest point on a parabola is the maximum, and the lowest point, right, is called the minimum. So the highest point is the max, and the lowest point is the minimum. And this point is the vertex. Okay. Now, the vertical line that passes through the vertex and divides the parabola into two symmetric parts is called the axis of symmetry. Okay, and I like to use AOS for abbreviation. All right. Now let's look at this graph right here. It's a parabola, and if you notice the axis of symmetry, right, it divides the graph into two equal halves. And then at the bottom is the vertex. Now the vertex, if you notice, is that point in the graph where the graph changes direction. So if you trace along the graph, you'll notice that at the vertex, that's where the graph stops going down and starts going up. All right. So that's why it's called the vertex. And if we look at a parabola where the opening faces down, okay, the parabola in this case is a maximum. And so it's a point where the graph changes directions from going up to going down. So this is the vertex and at a maximum point, and this is the vertex at a minimum point. Now, if you notice these 2 points on the graph, right? Now, the distance from this point on the graph to the axis of symmetry is the same distance from this point to the axis of symmetry. And similarly, at x-intercepts, right? The distance from this point to the axis of symmetry is the same as the distance from this point to the axis of symmetry. All right. So a few things about the parabola. All right, let's move on. Here you're given a function and a graph, and you're asked to determine the domain. Remember, domain, we're talking about x values, all the possible x values for this function. And this graph never stops, right? It has arrows. It just tells you that the graph just keeps on going and going, okay? And so for the domain now, we're looking at all the possible x values. And if you notice, any point on the graph, if I draw any point on the graph towards the x-axis, right, it's just going to decrease all the way to negative infinity. And similar on the right, any point on the graph, all right, if I draw any point on the graph to the x-axis, right, if you notice, right, that x value is going to keep on going to positive infinity. So on the left side, for my domain, it's going to be negative infinity, and on the right, it's going to be positive infinity. And the symbol we use for that is the less than inequality. And then we use, because we're talking about domain, we put an X in the middle, okay? Or we may use the all real numbers symbol. Now, let's talk about the range. Now, the range, we're talking about the height, the y values, okay, or the height of the function. So let me erase this for a second and get some more space. Now, let's look at this graph. The highest point on this graph, right, the highest point on this graph is this point right here, which is 6. So that's the highest point. So that's going to be on my right side. Now, the lowest point, now we're talking about the y values. The lowest point on this graph, you notice this graph just keeps on going down, right? This is -3. This keeps on going down. And so it goes all the way to negative infinity. It just never stops. And so negative infinity is the lowest point on the graph. And of course, we're going to use the less than symbol with that. Put y in the middle because we're talking about the y values. And because this is a solid line, at the point 6 is a solid line, all right, we're going to use the less than equal to. So that's my range. Place a box around the y-intercept. Now the y-intercept where the line crosses the y-axis. So I put a box right here. That's my y-intercept at the point 0, 4, and circle the x-intercepts. The x-intercepts all right there. Okay. What is the Let me clear this a little bit. What is the vertex of the quadratic function? The vertex, right? Remember, it's that point where the graph changes direction. So if you notice, the graph is coming up. It's coming up. Oh, let me erase that. The graph is coming up, and then it changes direction. Right. This is the point where it changes direction. So this is my vertex, and that is 2,6. So the vertex is 2,6, and it is a maximum, right? And again, it's a maximum because if you look at the parabola, it faces the opening, it faces down, and this is the highest point on the graph. So that's one way you can tell if it's a maximum or minimum. If the opening faces up, then you know you're gonna have a minimum. In this case, it faces down, so you have a maximum. What is the equation of the axis of symmetry? The equation is a line. It's a line that passes through the vertex, right? And it crosses the x-axis at a point um, 2. So the axis of symmetry is x equals 2. Now, a lot of kids make the mistake of using the point 2 comma 0 as the axis of symmetry. It is not, right? The equation is an equation, so you have to have an equal sign. It's x equals 2. All right, so let's erase that. All right, let's move on. Okay, 2 points on the graph. What is the equation for the axis of symmetry of the graph? Now, if these are 2 points on the graph, right, therefore the axis of symmetry is going to split the distance between those 2 points, right? So let's find the distance between those 2 points. Let's see. 1, 2, 3, 4, 5, 6. The distance is 6 units. 6 divided by 2 is 3. So at 3 units, that's where I'm going to place the axis of symmetry. So 1, 2, 3 right here. So the axis of symmetry is going to come through the middle. All right. And if you notice, it crosses the x-axis at a point -3. So the axis of symmetry is going to be x equals -3. All right, let's move on to the next one. Let's see what we have here. You're given the graph f of x is equal to x squared plus 2x minus 8. And you're asked to put a box around the y-intercept on the graph and write the coordinates as an ordered pair. So put a box around the y-intercept. Well, the y-intercept, a box. The y-intercept is right here at a point 0, -8. 0, -8. That is the y-intercept. And circle the x-intercept on a graph and write the x value of each. Well, the x-intercepts are here and here, and they are -4, -4, and +2. All right, -4 and 2. What is the domain of the graph? Again, the graph is continuous. It never stops. It keeps on going, right? And so the domain is going to be using inequality. It's going to be -infinity. Okay, less than x is less than +infinity. All right. Because remember now, it's going to be all possible x values. All right. So all the x values, this graph just keeps on going, and all the x values goes that way, and on the positive side, all the positive x values, all right, just keeps on going to the right. So that's the inequality. What number B is, what are the coordinates of the vertex of a graph? Well, let me erase this for a second so you can see more clearly. The vertex, again, is the lowest point on the graph, right? That's the point where the graph changes direction. All right, so this is the lowest point on the graph, okay? And that point is -1, -9. So my vertex is -1, -9. And is it a maximum or minimum? Well, remember now, if the graph opens upwards, right? If it opens upwards, then you're gonna have a minimum, right? So this is gonna be a minimum. Okay. So let me just clarify this. If the graph opens up, then you're gonna have a minimum. If it's open downwards, then you're gonna have a max, right? So this is a max, this is a min. What is the range of the graph? Now the range, right? Let's look at the lowest point on the graph. The lowest point on the graph is -9. So the lowest point is going to be -9. That's the lowest point on the y-axis. And remember now, as the graph goes up, the y value just keeps on increasing. All right. And so I'm going to have a positive infinity as my highest point. I'm going to use a less than symbol with that. And we're talking about range. And because at the point at -9, it's a solid line, right? It's a solid line, and so I'm going to use a less than or equal to symbol. All right, let's see. Let's move on to the next one. What do we have here? Which of the following would be the equation for the axis symmetry for the graph? Circle one. Oh, this is the same graph we're talking. I'm sorry. Okay. See. Okay. Okay. So got pushed on to the next page. So what will be the equation for the axis symmetry? Well, let's see. Okay. Now remember, the axis symmetry passes the vertex, right? So if I use, let's go with a red color. So this is a vertex on my line. My axis symmetry is going to pass through this point all the way up to the x-axis. And so that's going to be -1, right? So my equation now is going to be x equals to -1. X equals, think that. That's my axis symmetry. Solve x squared plus 2x minus 8 by factoring. Okay, so let's solve this by factoring. Let's do X box and see what do we get when we factor this. Okay, remember my first box gets X squared. My last box gets -8. And I need to find these two boxes. So I jump over to my X. My top number is going to be -8. My bottom number is going to be 2. I need two numbers. So when I add them, it gives me 2. But when I multiply them, it gives me -8. And those numbers are 4 and -2. So this is a 4x. That's a -2x. We know this is going to give me x right here. Okay, let me use a different color. It's going to be x here and an x there. What times x gives me -2x? That's -2. What times x gives me 4x? That's 4. And so my factors are x minus 2 times x plus 4, and that is equal to 0. And so if I set x minus 2 equal to 0, and x plus 4 equal to 0. Now, if I add for the left equation, if I add a plus 2 to both sides, that will give me x is equal to 2. On the left equation, if I add a -4 to both sides, that's going to give me x equals -4. And so we have 2 and -4. Okay, let's see. Let's go back and look at a graph, and we'll notice that the solution that we got on the previous page, right, is the same as the x-intercept, 2 and -4, right? 2 and -4, all right? So what this is telling you then is that the solution to the equation, right, is actually the x x-intercepts are the zeros. Okay, let's look at this one. You're given the function x squared minus 4x plus 3 shown below. Solve the equation by factoring. And what do you notice about the solution and the x-intercept? Now, based upon the last example, right, once I solve this equation, right, the solution should be the same as the x-intercept. Let's go ahead and verify that. Let's see. The x-intercept here is 1 and 1 and 1, 2, 3, 1 and 3. Okay, so let's see if that's what I get. 1 and 3. Let's factor this. Okay, I need some space. Okay, let's use x. Let's use put the x right here and put a box right here. Okay, and so for the equation, I'm going to have x squared here, and I'm going to have 3. I got to fill these out. So let's see. On the top of the x, I'm going to have 3. On the bottom, I'm going to have a -4. So what two numbers, when I add them, gives me -4, but when I multiply them, gives me 3. That is -1 and -3. So this will give me a -x and a -3x. Okay, so you know I'm going to have an x here and an x there. And what times x gives me -3x, that's a -3. And what time this x gives me a -x, that's a -1. Okay, and so my factors are x minus 3 and x minus 1 equal to 0. And so if I set x minus 3 to 0, x minus 3 equals 0. If I add a plus 3 to both sides, that will give me x equals 3. Okay? That's right there. Let's look at x minus 1 now. X minus 1 equal to 0. If I add 1 to both sides, that will give me x equals 1. So the solution to the equation is actually the zeros where the line crosses the x-axis, right? And so, okay, they're the same. Okay, and then another name for x-intercepts are the zeros. Okay, all right, let's move on to this one, number 5. Give the graph, find the following, the vertex. All right, remember the vertex is the lowest point on the graph, right? So the vertex is right here, and that is -2, -16, -2, comma, -16. And the axis of symmetry. Now, if you notice now, the axis of symmetry is going to pass through the vertex at the x value. So if I draw a line, it's going to pass through -2 on the x-axis all the way to -2 at the vertex. So just by looking at the vertex, I can tell you that my axis of symmetry is going to be x equals -2. If you notice, -2, -2. All right. Just don't put the vertex up. Just don't put the axis of symmetry as -2, comma, -16. That's a common mistake. That is not the axis of symmetry. All right. That is not. Just make sure you don't make that mistake. Y-intercept is where the line crosses the y-axis, and that is 0, -12. 0, -12. That is the y-intercept. Happens at 0, -12. And my zeros are -6 and 2. My zeros are -6 and 2. Okay? Okay, let's see. What else do we have? Last one. Okay, and so we're given the zeros, and we know that the factors are x plus 6 and x minus 2, and you want to write it out in expanded form. This we did was several weeks ago, right? We want to write this in an expanded form. So we got to multiply these out. And I remember we did the X box method to multiply two factors, right? We put X, one factor on the side, and the other one on top, X and -2. And then we use this X to multiply the factors on top. So we're going to have X times X is X squared. X times -2 is -2X. And on that, we're going to use the bottom. We're going to use for the bottom row now, we're going to use a 6 now to multiply the factors on top. 6 times X is 6X, and 6 times -2 is -12. And so remember, the first term is going to be it's going to be X squared. My last term is going to be -12. We're going to add these two in the middle, and that's going to give me plus 6X and -2X. And when I add those, I get X squared, 6 and -2, that's plus 4X minus 12. Okay. So, and that is equal to 0. All right. And I think that was the last question. All right.